landing a man on the moon and returning him safely to the Earth.
Tranquility Base here. The Eagle has landed.
Good afternoon and welcome to NASA's Johnson Space Center. I'm Chelsea Bayarte here live in Mission Control Houston. We're on flight day 10 of NASA's Artemis 1 mission, and today the Orion spacecraft will conduct a translational burn to insert the spacecraft into a distant retrograde orbit, or DRO. This is a relatively quick burn expected to fire for 1 minute 28 seconds beginning at 3:52 and 28 seconds p.m. Central Time, 4:52 p.m. and 28 seconds Eastern. Distant retrograde orbit is highly elliptical, oval-shaped orbit around the moon. This orbit is unique to Artemis 1 and will not be used for Artemis 2, Artemis 3, and beyond. It's highly stable, so little fuel is required to stay there as we use this Artemis 1 mission to put Orion's systems to the test. And here to talk about future orbits in just a little bit is NASA's Deb Ludbin. She'll be joining us as a guest shortly on in our coverage later today. We'll also be joined by NASA's Dan Hewitt back at the moon board to explain a little bit more about what distant retrograde orbit is. We're here live in Mission Control's White Flight Control Room with NASA Flight Director Rick LeBrode at the helm, overseeing a team of flight controllers who are getting ready for the distant retrograde orbit insertion burn. This is the same building as the International Space Station's Flight Control Room, but it's a separate room dedicated to overseeing Artemis missions. This is a live view that you're getting on your screen now. So let's talk a little bit more about how we got to this point. The spacecraft launched on a Space Launch System rocket on November 16th, and by its third day, it was halfway to the moon. On November 21st, Orion performed an outbound powered flyby burn, the first of 2 maneuvers required to enter DRO, the second being today's orbital insertion burn. At the time of outbound powered flyby, Orion was just 81 miles above the lunar surface. And throughout the mission, the spacecraft performed a series of outbound trajectory correction burns to put Orion into the proper configuration to enter distant retrograde orbit. So remember the number that I just told you, 81 miles above the lunar surface on November 21st, and by November 22nd, Orion exited the gravitational sphere of influence on the moon and was at a lunar altitude of nearly 40,000 miles. It's going to continue to get farther, and shortly after today's distant retrograde orbit insertion burn, Orion will reach its maximum distance from the moon at 57,287.76 statute miles. Tomorrow, November 26th, Orion will pass the distance record for the human-rated spacecraft originally set by Apollo 13. That record is 248,655 miles away from the Earth. Orion is expected to break that record at 7:40 a.m. Central, 8:40 a.m. Eastern tomorrow. If you want to hear a little bit more about that, head over to @NASA's Twitter feed or the Artemis blog, where you can listen to an in-depth audio-only conversation about the milestone with guests like Apollo Flight Director Jerry Griffin, Artemis's Najude Moranci, and more. So we're talking about the Apollo 13 record. We know that Apollo 13 traveled, here's that number again, 248,655 miles away from the Earth, and Orion will break that record on November 26th, but Orion isn't going to stop there. It's going to continue on to its maximum distance from the Earth, reaching approximately 272,514.9 miles away from the Earth on November 28th. We won't be live on air for that milestone, but later that day on Monday, we'll be live on NASA TV for a briefing to discuss the midway point of the Artemis mission. And finally, on November 30th, we'll be at the tail end of distant retrograde orbit. We're inserting into that orbit today, and Orion will leave DRO on Wednesday, November 30th to prepare for a splashdown back on Earth. So that was a lot of numbers and dates that I just gave you. We're talking about Orion's distance from the Earth, but also Orion's distance from the lunar surface. It gets a little complicated. So to get a visualization of both of these positions in real time, the Orion program has a great tool online called ARROW, or the Artemis Real-Time Orbit website. We link to it in the Artemis blog, and it's a way for you to see for yourself where the spacecraft is relative to the Earth and the Moon. On your screen now is a look at ARROW. This is what it would look like on your browser. So to recap, we're in a 25.5-day Artemis mission to the Moon, and we're in flight day 10. So far in the mission, Artemis performed an outbound powered flyby of the Moon and reached its closest approach to the Moon, and then it moved further away from the surface of the Moon and exited the lunar sphere of influence. Orion has conducted a number of burns to get ready for distant retrograde orbit insertion, and at 3:52 p.m., the burn is expected to begin just less than 15 minutes from now. So today, the milestone for the Orion spacecraft that we're talking about today is the burn to get into a distant retrograde orbit, the distant retrograde orbit insertion burn. So to talk a little bit more about this orbit, let's go to Dan Hewitt at the Moon Board, who can explain a little bit more about what it's all about.
The outbound powered flyby has been complete. We are on our way now to distant retrograde orbit, or DRO. Now we're going to do a maneuver to put ourselves into this orbit and to maintain it. We're going to be about 38,000 miles away from the lunar surface as we orbit around. That's part of why we're calling it distant. And we call it retrograde because the Moon orbiting the Earth in this direction, and then we're entering into our orbit in this direction. Opposites, retrograde. Now we're choosing this orbit because it's extremely stable. It doesn't cost a lot of fuel to maintain your position there, and that gives all of our engineers, our flight controllers, the chance to really learn about Orion systems in deep space. We'll learn about flying a spacecraft farther than we've ever sent one intended for humans. We're going beyond anywhere we ever went for Apollo. And so we're going to be in that orbit, test out all of those systems. Eventually we'll do a maneuver to break out of that, do another flyby and come home. But for now, looking forward to getting into DRO and really getting our chance to learn about Orion on this Artemis 1 flight.
So that was a little primer on what this orbit is and why we want to use this mission to meet our test objectives of the Orion spacecraft, but DRO will not be used in future Artemis missions. I'm joined now by Deb Ludbin with NASA's Gateway program. Hey Deb, thanks for joining us.
Thanks so much, Chelsea.
So Deb, Gateway is not going to be in a distant retrograde orbit, is it? What will the lunar outpost be in?
It will not be in a distant retrograde orbit. The Gateway will actually be in a near rectilinear halo orbit, which is a lot of words. We say NRHO, and that is a very different orbit than the DRO. Would you like me to explain a little bit about it?
Yeah, sure.
Okay, so the NRHO, near rectilinear halo orbit, is much more long and skinny, like a long oval. So it actually looks, if you're looking at the moon, more like a necklace hanging down from the moon. It is sort of a combination between two types of orbits that have a lot of things going for it. So the low lunar orbit is more similar to what Apollo did, and that's an orbit that goes sort of around the center of the moon, and it's very close, and it provides great access to the moon. And then the DRO, the distant retrograde orbit, is a much broader, and it usually takes about 2 weeks to get around in an orbit, and it's very circular, and it has great stability, which means you don't need a lot of fuel to stay in orbit, but it also is not very close to the moon. So what we have for the Gateway is we have a near rectilinear halo orbit, NRHO, and that orbit has the benefits of both. So it is both access close to the moon for some of its orbit, where we get to about 90 miles away from the lunar surface, but it also has the stability of a distant retrograde orbit, so its overall orbit takes about a week, 6.5 days or so, and that orbit offers both the stability of a distant retrograde orbit as well as the access to the lunar surface that a low lunar orbit would have.
Wow, that's really cool. And you're seeing the Gateway that we're talking about now on your screen. And I also see Orion in this graphic. So we heard that Gateway is going to be in this NRHO orbit. Does that mean Orion's going to have to be too?
Sure will. So Orion will do lots of things for Gateway. Orion is the crewed system that will bring crew out to the Gateway so that we can live and work and test out those systems. But at the same time, Orion is going to be bringing some other things out to lunar orbit for us too. So it's very important that the Gateway is in an orbit that both Orion and the human landing system can both access, and Orion will come right up to us.
So we know that Orion's going to need to be in the same orbit as Gateway during future missions, as you just told us. But can you tell us about Orion as a whole? What's its relationship to Gateway, and what's the goal of Gateway, and how does Orion help?
Absolutely. So like I said, Orion is the only way right now that we have to get crew to the Gateway. So that is our number one reason for making sure that we have the staging point of the Gateway small space station in lunar orbit. We can use that as a staging point for Orion to come out and for the human landing system to come out, and everything can meet together there. We can do system checkouts on all of the systems that we will need to go down to the lunar surface, and the Orion crew, which is the Artemis crew at that point, can learn what it's like to live and work farther away from Earth, and learn what it's like to be longer in space, and what happens to people when we're farther away from Earth, when we're significantly farther away from phoning home and calling for help. And so we're using this opportunity with the Gateway to test out all of those systems, both technical and human systems, to make sure that we can work together as an integrated system, which will absolutely be necessary for Mars.
That's right. So we're talking about going to the moon, going to Mars, the Gateway overall. Why is Gateway important part of the Artemis missions?
Gateway is imperative in figuring out how we do a sustainable lunar mission. The Gateway is crew tended. It is not crew habitation all year round. We have crew there for about a month at a time. And for our longer missions, the farther we get away from Earth, the more independent these systems have to be. So we utilize the time on Gateway in learning more about what our systems will do, what our people will do, and it's also a great staging point for future missions. We could actually launch a Mars mission from a system at Gateway, do all of the staging, all the checkouts there, and then have it move on to Mars. And at the same time, we do tons of science. So the good thing about Gateway being there all the time and it being a sustainable system is that we can use that to do science experiments and learn about space weather, learn about radiation, learn about what systems are going to do when they're tended and when they're not tended for significant periods of time. So the Gateway is an imperative position for us enabling sustainable lunar orbit as well as moving forward to Mars.
And that's what it's all about, a sustainable presence on the moon and the science that we can achieve from it. Deb, thank you so much for joining us.
Thank you, Chelsea.
Thanks. We're now coming up on about 6 minutes left until the burn. Shortly before our coverage began today, Flight Director Rick LeBrode conducted a go, no-go poll for the burn, consulting with flight controllers here in the White Flight Control Room, and they all concurred that they are go to proceed with this burn. This distant retrograde insertion burn is expected at 3:52 p.m. Central Time, 4:52 p.m. Eastern. It's going to fire for 1 minute and 28 seconds. Four minutes now until the expected start time of the burn. Now less than 3 minutes away from the burn. You're looking now at an animation of the Orion spacecraft. We intermittently have live views of the Orion spacecraft from its onboard cameras when they're available to us. It's still to be determined whether we'll get live views during this burn or not. And with 1 minute left to go until the burn, it looks like we do have our live views back. "30 seconds away from the expected start of the burn." And we've confirmed that the burn has begun. The burn is nominal so far. Everything proceeding nominally. We're continuing to hear good callouts from flight controllers monitoring the burn. We've reached the end of the burn. The engine has stopped firing. You're getting live views from Mission Control now. We received good callouts of the burn while the burn itself was going on. Flight controllers are just confirming that everything went well. Our coverage today is all about distant retrograde orbit insertion burn, which just commenced minutes ago and concluded about just a little over a minute afterwards. We're back with live views of the spacecraft now. Flight controllers here in the white flight control room looked at all the data from the burn and confirmed that it was a good burn. The burn began as scheduled at 3:52 p.m. Central Time, burning for almost a minute and a half. So it looks like we had a good burn. It began at 3:52 p.m. Central Time, 4:52 p.m. Eastern, burning for 1 minute and 28 seconds. This burn occurred. The start of the burn began about 10 minutes ago. Orion is now traveling at a velocity of 2,252 miles per hour, 57,000 miles above the surface of the moon. And you can follow all of this data in real time using the Arrow Artemis real-time online tracker yourself. We link to this in the blog. We're going to continue to have imagery and videos in high definition from this mission as well as we go on. This is a 25-and-a-half-day mission to the moon and back, and we're on flight day 10, having just completed the distant retrograde insertion burn. Many important milestones are expected. We'll be live on air to discuss the midpoint of the mission and for distant retrograde departure as well when the Orion spacecraft departs this distant retrograde orbit that it just entered today. Until then, the next milestone that we have coming up will actually focus on the International Space Station. Live coverage of the SpaceX Commercial Resupply Services 26 mission. It's a cargo mission with the Dragon resupply spacecraft. Begins at 2 p.m. on Saturday, November 26th, with a launch scheduled for 2:20 p.m. Eastern Time. That concludes our coverage for today. This is Mission Control Houston.